Hello everyone, welcome to my YouTube channel. My name is Precious. Right, so this is a request video from one of our students. He's asking us to look at this particular problem here. Okay, so and this is from partial fractions, what some people call one linear, one quadratic as the denominator. Remember, we treated partial fractions. You will need to look at the videos, and of course this was actually covered there. This will be a combination of two of the categories we looked at. One is a category of where you have repeated linear, you can see it here, and then you have a quadratic. So how do you handle that? So we're going to be combining those two. You remember that whenever you have a repeated linear, that what you would do, let this be equivalent to the first one will be your a. You choose a constant a all over one of those linear factors, which is x plus 1. That's this. Then plus, you will now have b all over the whole of the linear factors, which is x plus 1 all squared. And then you now have the third one plus c. Now the third one now is going to be for the quadratic. And remember that the numerator of the quadratic is usually together with x and then another constant. So we use cx plus d then all over our denominator here, which will be x squared plus 1. That's a quadratic factor. Okay, so our job now is to get the value of a, b, c, and d, and then substitute here, and that will be our partial fraction. Remember that all we're asked to do here is to split this particular fraction into its partial fractions. Okay, so now let's go. You recall that the first thing to do here is to get our LCM, and the LCM here is going to be x plus 1 all squared. Okay, so now we'll try to simplify. X plus 1 divide this, you have x plus 1 multiplying this left. So you are going to have a times, and so we are done with this one. So we come over here. So the x plus 1 squared will divide, so only this one will be left, and that will multiply your b. So you're going to have b into x squared plus 1. And then we come over here. Of course, the numerator is going to multiply. So we're going to have cx plus d multiplying. When this divides the denominator, you have only x plus 1 all squared. And so you're going to have x plus 1 all squared here. Try to compare the numerator. Since the denominators are the same, they will simply cancel out. Okay, so we now compare the numerators. So this now implies that 2x cubed plus 2x squared. So at this point now, we can now start trying to look for our a, b, c, and d. And one of the things we can do is to try to eliminate some of the constants. Here we can actually eliminate a and then c and d by putting our x as minus 1. So if I say let x be negative 1, what will happen here is that if I put x as negative 1 here, I'm going to have negative 1 raised to the power of 3, and that is negative 1. So that negative 1 times 2 is negative 2. Then plus here, negative 1 raised to the power of 2 is going to be 1. 1 times 2 is 2. And finally, we'll have plus 2 here. And this will now be equal to, so on the right hand side now, if you put negative 1 here, this will turn to 0. So everything here becomes 0. Now, the same thing here. If you put negative 1 here, this will turn to 0. And 0 squared is 0. And so when that 0 multiplies this, you also get 0. So you only have on the right hand side b into x squared plus 1. And so at this point, all I'll need to do now is to now simplify. So this will take away this. And so I will simply, recall that here, if you put your x as negative 1, that's going to give you negative 1 squared, which is also 1. So this is actually equal to 2b. So you will eventually have 2 equal to 2b. And when you divide both sides by 2, then our b becomes 1. So we have gotten one of our require the constants. So we need to get the other two. Okay, so to get the other other three, sorry, we need to expand what we have here, because there is no other substitution we can make. Any other substitution we make here is not going to cancel out any constant. So we try to, simplify out what we have on the right hand side. So here we have 2x cubed plus 2x squared plus 2 to be equivalent to, so if we expand here, we are going to have a into, this will give us s cubed. That's x will multiply x squared, so we'll have s cubed. X will multiply 1 and we'll have x, and then again 1 will multiply x squared, we'll have x squared, and 1 will multiply 1 to give us 1. So, and that is plus b. If you open that bracket, you get bx squared plus b. Then finally, if you open the last bracket there, we are going to have, but before we do the final opening, which is, we first of all keep this one and then open the one that is at the end, that is this one. So if we open that one, we will have x squared plus 2x plus 1. Okay, try to do that. Of course, we have done polynomials here on this channel. Try to do that expansion. Okay, so we'll try to open the last bracket and the first here. So this is going to become ax cubed, and then that's going to be plus bx squared plus b, and then finally, if I now open here, cx times x squared will be, okay, let me use this one. So this is going to be cx squared, sorry, cs cubed. Okay, so now cx times 2x is going to be 2cx squared, and then cx times 1 will be cx, and then we use d times x squared will be dx squared, d times 2x will be 2 dx, and finally d times 1 will be d. Collect like terms. Let all that contain s cubed be in one bracket, and the same thing for others. So this one has s cubed, this is another one that has s cubed. So I will factorize, put the coefficients in one bracket. So I have a plus c, and then bring out the s cubed. And then I'll go for x squared. This one has square, this one has square, there is square here, and there is a, so you have about 4 of them. So I have plus in a bracket, I'll take all their coefficients. A is here, then B is here, then I have 2C, then I have D. That's in the last one, and then you open your bracket, you have x squared. Of course, if you open back this bracket, you will get everything that we had initially. So we go for x. All the ones that contain x, this one has x. What again? This one has x, and then this, about 3. So here we have a plus c plus 2d are all the ones that contain x. And finally, we go for the ones that don't have x at all, and they include this one, and then this. Is that all? Is there any other one that, okay, there's b here. Okay, so finally there we are going to have, let me see if it will enter here. So we have a plus b plus d as the constants. Okay, so now remember, we are comparing it to what you have on the left hand side, which is 2x cubed plus 2x squared plus 2, right? So comparing both sides now, you remember that when we talked about the concept of equivalent polynomials, if two polynomials are equivalent, then their coefficients, the coefficient of corresponding variables must be equal. That means the coefficient of s cubed must be equal to the coefficient of s cubed on both sides. So let's begin with that. So what it implies is that a plus c, which is the coefficient of s cubed here, must be equal to 2. I can call this equation 1. Okay, and then what else do I need? Remember, you pick this according to your need. So the very best option to pick here is the coefficient of x. On the right hand side, the coefficient of x is a plus c plus 2d, and that is equal to the coefficient of x on the left hand side. There is no x here, so we assume that the coefficient is what? 0. This is equation 2. Now, why did I choose to go for coefficient of x? Because that will immediately help me to get my d. And how is that possible? Look at it now. At this point, if equation 1 says that a plus c is 2, and I have a plus c in equation 2, I can quickly substitute that. So I'm going to have 2 plus 2d is equal to 0. Remember, I'm replacing a plus c as equal to 2 being what we have in equation 1. So I'll quickly now solve this. So this is going to give me 2d is equal to, this coming here becomes minus 2. Divide both sides by 2. Therefore, my d is equal to negative 1. Okay, so I haven't gotten my d. What else can I do? Recall that I have the value of value of b and d now. So I can actually get a using the constant. So if we equate the constants on both sides, it means that a plus b plus d must be equal to the constant on the left hand side, which is what? 2. And now I have my b as 1, I have my d as negative 1, and that is equal to 2. Of course, positive 1 will take away negative 1, therefore my a is equal to what? 2. So now I have a, b, and d, so I need to get my c. And then I can finally use this other equation also here. We can use this one. Either of the two will give us our solution. Okay, so let's quickly make use of this one. And so if we use this, we are going to have that a plus c plus 2d is equal to the coefficient of x on the left hand side, which is 0. And so I have my a as 2, and I have my c as what I'm looking for, and my d is negative 1. So this is 2 times minus 1. Everything is 0. And of course, 2 times minus 1 is minus 2. And this minus 2 will take away this positive 2. Therefore, my c is equal to 0. So now I have all the values that I am looking for, and we can quickly put them into the equation that we formed here. Let's go back there. Is that our partial fraction is a is 2 all over x plus 1, b is 1 all over x plus 1 all squared, and then our c is 0, so the whole of this will turn to 0, and then our d is negative 1, so we have negative 1 all over x squared, and that is our solution. Now, if you like, you can actually join this fraction together. You will definitely get back what we started with. So that is the solution to this problem, and you can go over it again to see the processes that is involved. Remember, I said that it involves just 2 of the types that we considered earlier, which is when you have a repeated distinct denominator, and then when you have a quadratic denominator. So we combine those two to get the solution to this problem. And so please kindly subscribe to our YouTube channel. Do like, share our YouTube videos, and we'll see you in our next video. Bye.